So, first of all, what are all of these shapes on the first page? All of them are rectangles. So all of them are what? Just go put this here. Yeah, four-sided, and all of them obey the same. By the way, they want you to calculate what and what of each shape. Here it is. What and what. Not just one thing, but two. They want you to calculate what? Perimeter, which is the outside length if you go around. So the perimeter. And, okay, let's look at the first one. Perimeter of any rectangle is just what? Imagine me going around. What do you just do? Exactly. So length plus width, or two lengths plus two widths, like you double. So one way you could do this is this. Look, P equals 2 times, what's the length of this piece? How long is that piece? That strip? 27. 20, 27. Come on, 27 plus 2 times, what's the width of the piece? 0.32. All right. Let's do this step by step. Equals. Well, I know that 2 times 27 is 54. And I know that 2 times, or the double of 8.32 is 16.64. So if you add this up, you get 70, 50, 70.64. In what? In what units? Oh, hold on. Now, is this area or just perimeter? Exact. Perimeter is just the length of the string you wrap around. So just what? That's centimeters. No problem. Did you get the same answer? Then I can't say that you're wrong. This just takes less time slightly. Okay, let's do area in green. Hey, Mal. Let's do area in greens. I mean in blue. Sorry. What's area? What times what of a rectangle only? Length times width. Now, yesterday, someone here called it pace times height. I think it was Jalil. I can't say it's incorrect, but the more neutral way or common way is length times width. Well, how long is the strip? Yeah, 27, but this time times 8.32. Well, okay. Wait, how long? How much? Because I think it should be higher. Look, 27 times 8. Yeah, 200 something. Look. Do you remember what you did? I'm always interested in what people plugged in. Two- Oh, as a measurement. That should not change things. The only explanation I have is you punched in something incorrect or something. Hey, Brooklyn. Would they be able to help you with it? Okay. No problem. So, okay. So 224.64. But in what unit now? Centimeters what? Squared, because it's an area of the inside. Nice. All right. Let's do the next one. Okay. I know this is AU, and I wanted to tell you, but I forgot. AU. Yeah, you're right. AU is a unit, right? Because centimeters and AU. Okay. And I don't want you to feel. Oh, I thought you were talking about this. AU, and again, you don't need to know this. AU stands for atomic unit. What it means, look, what it means is, how many people did chemistry here or grade 10 science or something? So you know that the atom is made of what? Has a nucleus in it, right? Are those things, and what's inside the nucleus? Protons, neutrons, and flying around the electrons. Are those things big or small? How small? Extremely small, right? So do you think they're measured in millimeters or even nanometers? Even, yeah, even smaller. Well, they designed a unit just for that small scale, and they called it what? Atomic unit. You know what? You are more than welcome to change it to any unit you feel comfortable with. Kilometers, centimeters, or you know what? How about we just don't do any units, right? 41. 41 what? Whatever. So everyone, go ahead and scratch this. We don't care what unit is measured in. We just care that the length is 41. 41 something. Or sorry, 41 units or 41 things. Okay, perimeter. Can we do the exact same thing we did for the first rectangle? 100%. So I'm going to say here, I think we did perimeter in red. P equals, you know what? I'm going to see if I can fit some here. 2 times 44.20 plus 2 times 41. Okay, that will give you, not sure, I'm just going to give you the final answer. 44.2, 44.2, 44.2 times 2 plus 2 times 41. Well, I know that in my head it's 82. Boom, that's it. 170. 170 what? Well, it should be 170 atomic units. Sorry, 170.4. Hold on. 129. Maybe. Oh, I think you might have maybe. Oh, I know what you did. You multiplied this by 2, but then you added plus just a single 41 instead of two 41. Yeah, definitely. That's how you get 129. Okay, how about the area? You just multiply what by what? Come on. Length times width. So really here is just the 44.2 times. I'm going to do the vertical multiplication like back in grade school. And this would be 1600 something. I know it's a big number. There you go. Yeah, so more than 1600. 1800. So 1800. 1812. Point what? Point 2. This should be in atomic units squared, but we're skipping that. There we go. That's it. Okay. Because I really want to get what into the triangles and trapezoids and circles, I just want to do one more of those very easy rectangles to jump to the next step. So which one should we do? I'll take a vote. Which one? Okay. So yeah, go ahead. Oh, sure. So you want me to do this one, number 4? Okay. Ty has spoken. Let's do number 4. Okay. Is there anything? Can I just see the thing? Yeah, they're all more or less the same. Okay. So everyone, we will do this one. Okay. You know what's? Look, everyone. I think. Do you have enough space inside of it? Yeah, you do. This not triangle, rectangle is so big we can actually do the calculations inside of it. All right. So P. What's my length? 46.2. So 2 times 46.2 plus 2 times what? How much? Is that 2919? Yeah, it is. 2919. How much is that? I don't know. Lots of decimals here. I need a machine. So 2, clear, clear, clear. Empty the 2 times 46.2 plus 2 times 2919. You know what? Let me actually show it to you step by step. 2 times 46.2 is 90. Oh, come on. 2 times 46.2 is 92.4. So 92.4 plus, I know this one. I can figure this one out. 2 times 2919 is 5838. Everyone, 5838. And the addition of those two is, 90, 50, 160, 150.78. In what units? Okay, millimeters or millimeters squared? Just millimeters because we're doing length. We are doing perimeter. So millimeter. Okay, how about the area? Much easier and quicker calculation. You just do area equals, yep, 46.2. I like to start with the longest one first. although you would be correct if you started with the shorter one, 29.19. How much is that? By the way, you could have written the area calculation here if you like. Everyone, you could have written the calculation for area here because you've got space. But 46.2 times 2919. 1, 3, 4, 8, 5, 7, 8. By the way, just so you know, remember how many decimals we always rounded to in money? In money was what? 2. Here, and why was it in money 2? Because you can never go more than what? 2 cents, like so, like 2 places with cents. Yes. However, in geometry or in pretty much anything else, I can choose 1 for you. I can choose 2. I can choose 3. Usually, I'm not gonna choose 3. That's just a lot of digits to show. It's either gonna be 1 or 2, or sometimes nothing. Like, sorry, not nothing. I mean, no decimals, like whole numbers. Yes, sure. Okay, so what was the number? 1, 3, 4, 8, 5, 7, 8. Let's just keep the whole thing. 1, 3, 4, 8.578. In what unit this time? Millimeters, but it can't just be millimeters. It has to be squared because it's a squared area. Perfect. Done. That's it. Okay, so this is how you deal with absolutely any rectangle. All right. What was the next page? What shapes? Triangle. Okay, just slightly more complicated. So let's just go here and let me go to the next page. Zoom out. Yep, there we go. Okay, fine. Select all. There we go. Zoom, 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 zoom. Copy. All right. Next. New. Don't save. Hey, done. Okay. Let's look at the first one. All of them are triangles. Can someone quickly remind me what was the original equation for the area of any triangle? Any triangle. Of any triangle. Perimeter is easy. You just add the 3 sides. How about, yeah, what's up? Just give me 10 minutes and then we'll go. What's up? What's, no, no, that's the perimeter. I'm asking for the area. Uh-huh. Base times height divided by 2. Okay. Let's look at the first one. What's the perimeter here? Do you already have 3 sides? Sorry, do you have the 3 sides given or shown to you? Yes, you. By the way, you have to, because otherwise, how are you going to add the perimeter if you only know 2 sides if you can't add 3? So here, well, that's easy. We're just going to do 17. Go ahead. 17.7 plus. Doesn't matter in what order you want. I'll start here, go here, and then come back here. 17.7, 10.6 plus 14.2. Remember, a common trick, not with me, don't worry, but with other math teachers. Look, what do? They give you the numbers, but each number has a different what? What is that letter? Unit. Has a different unit. So they could give you meters for the long one, this vertical one, they could give it to you in yards, and the other one they could give it to you in centimeters or feet. I'm not gonna do that because if I do that, that becomes a harder job on you trying to switch the units all to agree on one thing. Nope. I'm just gonna give you the units all to be the same. So what would this be? 17 plus 10 is 27. 27 plus 14 is 41. But we still have the decimals, 0.7, 0.6, 0.2. That's 15. Who got 42.40? 42.2? I think you should get 42.5. Everyone look. 5, yeah. 17.7 plus 10.6 plus 14.2. Yep, 42.5. In what unit? Come on, people. What is the unit for perimeter? Just perimeter is the easy one. It's meter. All right. Area. What's the base of this triangle? Like, what's the ground distance? If you lay it on the ground like that, what's the base? 14.2. How high is it from ground to top? Done. That's it. So area equals what? Base times height, or 14.2 times 10.6, all dividing, this is 6 by the way, if it's not clear enough, 6, all dividing 2. What do you do first? You have to do, what's up? Sorry, did you say add? You said multiply. So multiply, what's up? All right. Okay, need to multiply this number. Well, I don't know what it is. I know it's like 140 something. I know that at least. 114.40.2 times 10.6. Okay. Yes. Yeah. Well, once I finish this one. 150, 52 divided by what? Remember, a common mistake is people forget to divide by 2. You don't lose many marks, but you still lose something. You know what? If it weren't just for that, yes, absolutely. Um, so what's 150 52 divided by 2? That would be 75.26. In what unit? Meters squared. There you go. Meters squared. Okay. How about the next one? Do you need the height in the inside to calculate the perimeter? Hmm. Do you need the height inside to calculate perimeter? No, because perimeter is only where? Around, which means what? On the outside. So, what's perimeter? I'm going to do it here. Perimeter equals, doesn't matter which one you start with. Let's start with the 7.4. So 7.4 plus 8 plus 8.1. Well, I can do this one. Yes, because 8, 8, 16 plus 23.5. What unit? Centimeters. Okay. How about the area now? Well, the area is base times height divided by 2. So, how wide is the base? No, just that. 8.1. How high is the height? Height, the vertical distance going straight up. Exactly, 6.5. All dividing 2. Okay, so that would be the top part. No, hold on. I think it should be bigger because I know 8 times 6 is at least 48. No, you divide by 2 at the end, but you need to do the top part first. So, 52.65. Again, one thing about doing math for so long is even if you don't know the right answer, at least you can, what's up? 56.65. Is that even though you don't know the exact answer, at least you can tell if some answer that someone says or the calculator says is even logical or not. Okay, and then we divide. So what would this be? Division by 2. So the area of this triangle is 26,325 in centimeters squared. 26, how much? 325 in squared centimeters. Done. That's it. You have to, but only at the end. Only at the end. Please never do it at the beginning. You're going to make a mistake if you do so. BEDMAS tells you so. BEDMAS tells you have to do the top part first, which is multiplication, and then divide. Okay, let's look at those triangles. Sorry. Any of them rotated, like spun 90 degrees or something? Not really. I mean, some. Did you say yes or no? Sorry. Let me just add another pane. Like, does any of them look like this, where they gave you? Yeah, but could I give you a triangle that looks like that? I could, but then where would the base be? Yes, Exactly. The base would be, everyone, the base would be this one. So imagine it's basically resting this way. Look, imagine it's resting not on the ground. Everyone, eyes on the screen. Imagine it's not resting on the ground, but imagine it's actually stuck to the wall. This becomes the base then, because this is how it's resting against a surface. So this becomes the base. Again, if I ever give you a triangle like that. So what becomes the height? Where is the height now? Yes, the height is basically in the middle, this guy. Look, everyone, the height would be how far is the top of it from the base. So this would be the height. Again, only if I give you a triangle like that. Okay, but apparently none of them looks like this, so they're all easier than this, like rotated idea. Okay, what are you looking for? Go ahead. Yeah, it's already open. Oh, just the latch. Nope, you have to click the button next to it, the button next to the combo. Yep, to the right. It should be 000, is it? Yep, just click it. Just flick it to the right. Just flick the. There you go. It is a briefcase. That tells me how unused your generation is to briefcases.
My mom has one.
Hey, for 3 years and
My
my my
mom has
my
an
high
actual
my
briefcase with a lot of bleach
uh,
stuff.
my grade 11 and 12, I had a briefcase in school. Our school was weird. Our school looked like freaking a business school. Everyone was walking with a no, seriously. Back back in '98, if you had a backpack in Saudi Arabia, actually, you know what, and you walk in school, you would be beaten for sure. I'm not sure why. Like, is it high school supposed to be? Yeah, people. I was walking with a Samsonite. I gotta say there were so many pockets in it. You know, you could put everything you wanted, and you just open it. That's it, and you take your books. But I'm telling you, it was like you don't see this ever. At least you see people wheeling the cases sometimes, right? No, we weren't like that, but we were like a business school. Everyone's like a business. So we don't have that. So let's do one of those simpler cases. I mean, we've just done a right angle one. So let's do this one. Come on, quick. So and yeah, well, number 5. So P 3 plus 3.1 plus 3.6 at the bottom. So 3 plus 3.1 plus 3.6 at the bottom. How much is that? 3 plus 3 plus 3 is 9. Point 0, point 1, point 6 is point 0.7. Thank you. In full kilometers. All right. How about the area? Well, that would be the base, which happens to be 3.6 times. There you go. Times what? Base times, yes. Not times this slanted, not times this slanted side, times straight up forward. So for upward, sorry, from base to height. So base to top. So that's the 2.5. So 3.6 times 2. I know this one. Yes, 3.6 times 2. Hold on a second. 3.6. Yes, you're right. No, he's right. Because I was thinking of the number before dividing by 2. It is 9. And then you get 4.5. In what unit? Well, it's still kilometers, but it's squared. Done. That's it. Okay. So the other triangles are more or less the same idea because none of them is like this. Look, none of them is like this. So they're supposed to be as easy as all of those ones. Okay. Okay, everyone. I know we have trapezoids coming up, but let's get done with the circles first because they are definitely quicker and easier than those trapezoid equations. Okay, let's go to the circle. So go to the other sheet, the second page. So zoom out to page level, go all the way down. There we go. Select all, zoom out to 20, 200. There we go. Sure, I'll take it. Okay, first one. What are you showing here? Are you showing the half or the full diameter? You are shown the whole thing, and how can you tell? It is cutting the circle from one side all the way to the what? To the other side, and it's passing through the what? Center, middle, center point. Yes, you can go. So that means it's diameter. Well, that's not good for us because we never use diameter. I could show it to you, but you can never use it, or you shouldn't use it, I should say. What is it? Sorry, what do we need to find from the diameter? So what's the name of it? What do you call the distance from the middle to what? Radius. So all I have to do is do what to the 7.8? Double it or divide it by 2? Yeah, I don't need double of it. I need half of it. Whenever you want half, you just divide anything by 2. So everyone, let's just write something here. Let's actually write radius here. Radius. Radius equals 7.8 divided by 2. Okay, if that circle is as big as 7.8 in diameter from side to side, then half the distance inside of it from the center to the rim is, as Jake said, 3.9 in what? Well, it's still in centimeters. All right. So that takes care of just the radius calculation, which is not really much of the solution to the problem itself as much as a step you needed to do to get things in the right direction. All right. Can someone tell me what's the equation for circumference? Like how long a string would wrap around, not inside. Yes, 2 times the pi times the radius. That's why you need to get the radius because you have to use only that. All right. So circumference. Okay. I think we have enough space. Let's write 2, everyone. 2 times 3.14 times radius, which was 3.9. I'm going to write it here. So what is that? I don't know. 2 times 3.14 times, you got that right, 24.492. But what's the unit? Remember, it's just how long you've walked around. So, yes, but is it squared or not squared? Not squared. Circumference is the length around the circle. So 24 point, is it 942 or 492? 492. 492, and as you all said, in centimeters. Can someone remember now or tell us what's the area? It's very similar to that, but the 2 has a different location. The 2 is not at the beginning. So the 2 migrates from the beginning all the way to the what? To the end, and not just the end. Where does it go? As a what? What do you call a number on top of another number? Come on, there are 2 names for it. Okay, so it squares it, but basically it becomes a what? It becomes what we call an exponent. How many people have heard the word exponent before? Yeah, that's bed mass. The E is or power. I like the word power because it's easy. Power is exponent. Yep. So 3.14 times what? Times 3.9. Please make sure you write the square always in a smaller handwriting and legit on top of the number to the right side of it a little bit. Okay, how are we going to do this calculation? Well, my advice, do the 3.9 square first. Do the 3.9 square first. So let me just zoom out so I have, yes, I'm going to do it right here. So let's do it as a square. So here it is, 3.9 squared. Is that a square? Yeah. Times what? What do I times this by? Come on, according to the calculation. I've already done the square part. What do I times that by? Come on, people. Nope. I've already squared it to the power of 2. What do I need to multiply that 15.21 by now? Exactly. I've already done this part. Now I need to times it by this. So I need to times it by 3.14. 47,7,5,9,4. I'm always going to ask you to either round to 1 or 2, but today let's just write the whatever number we get. So 47,7,5,9,4. 47, right? Yes, 47, 7, 7, 594. In what unit? It's an area. It's the inside. It's the inside space. It's the inside the space. Centimeters in squares. Thank you. Boom. Done. That's it. That's why I want to do the circles first, because their calculation was going to be direct and much quicker than trapezoids. Okay, next. What are you given here as well? Are you given the diameter? Okay, everyone, again, we have to calculate the exact same idea here. Radius. Radius. All right, I'm going to expand this a little bit. Oh, where's the... There we go. All right, radius is how much? Is 10.8 divided by how much? How do you get to the half of anything? If you want to get half of something, you divide it by 2 people. 5, 2. So you get what? You get 5.4 in what? Huh. I thought they would give you in inches or something. Nope, they kept it as centimeters. All right. Circumference. Circumference. Can I show you? Do you have the circles one? Oh, come on, man. I think you should. Good. Okay. So what's the circumference again? Same exact thing. What's the only number that would change here now? Do you ever change the 2? Do you ever change the pi? What do you change? Only the what? Yes, every circle has its own radius, as long as the circle is getting bigger or getting smaller. It's amazing. Yes, that's one. Yep. Look. It's amazing how every shape in the universe, everyone, every shape in the universe, you always need a bunch of what? A bunch of dimensions for it, like a bunch of sides. A rectangle, you need to know 2 sides, like length and width. A square, okay, fine. A square, you only need to know 1 side because you know everything else is the same. A triangle, you need to know 3 sides, legit. A circle, you just need to know one thing. All circle, by the way, everyone, all circles in the universe are the same shape, right? They just have different what? You can fit any circle perfectly in the middle of another circle, and they would line up perfectly. Everyone, this is what I mean. Look, everyone, just check this out. Let's put new. It's a bit of a side, comment, but everyone, look. And by the way, hold on. You know that when I sketch it here, is it gonna look like a circle or more like an oval? Why? It's not because Microsoft Paint is bad. It's because what? If the projector itself has a 16:9 or a 4:3 aspect ratio, so it's not perfect projection. It squishes it this way, or it stretches it this way. Either way, it elongates it up. Yeah. So everyone, look at this circle. Oh, I screwed it up. Trust me, it is a circle. Look at, I don't know if you can see the screen. Look, everyone. You can see the screen. Sarah, look. It's a perfect circle. It's not here, but here. Okay. I'm gonna sketch another circle. I'm gonna make it smaller. Oh, where is the center of the circle? That's why I like, everyone, look. That's why I like the grid points. The grid line. I can know. Yeah, look. The best thing about Microsoft Paint is whenever it sketches a circle, it tells me basically the perfect point in the middle here, the perfect point in the middle here, the perfect point in the middle here, which is lined up with this, and this one lined up with this. So if I line them up perfectly on one of the grid lines here, on one of the grid lines here, I'll know that the intersection of the grid lines is perfectly the circle. Let me show you what I mean. Like this. Okay, now I'm lined up vertically. I just need to line up. Boom. See? This and this, where do they meet? Right here. This is the center of the circle, non-negotiable. So the center of the circle is right here. I'm gonna sketch like a little dot or something. I need, yeah. So we said right here. How many people agree that this looks like indeed the circle, center of the circle? Okay, I need to sketch another one. Here's another circle. Look. Is this same size or smaller? Smaller. Oh, I screwed it up. See, you have to press shift all the time until you release it. Okay, that's it. There we go. Do you see how they perfectly line up? How many people see it? They perfectly line up. You know what that means? If those were, look, everyone, here's another way to think about it, Judy. If those were race tracks and two cars are what? Are racing, if they have the same speed, they would always be what? Different or together? They would be together, pointing exactly the same way. It's like this. Look, everyone, look. It's like two pens or two pencils, like this. Look. Oh, sorry. I have to look. Right? Like this the whole time. That's how amazing circles are. All circles look the same. They just have different size by having a different what diameter or radius. Either way. Okay. So let's go back to where is it? Here. So what's the circumference again? Everyone, come on. 2 times 2 times what? Come on. 3.41. Sorry, 3.14 times. Yeah.
Wow, you're mixing up pie there.
And I'm not just anyone. I'm a math teacher. Yikes.
Yeah.
Don't tell anyone.
Thomas is forward. Okay. I would never.
She would be like, I don't care. I'm a biologist. I don't care what math people do. No, it's this one. That one. No. Okay, so if I tie a string from here, from like the not one side, one point on the circle, and turn perfectly all the way back to that point, I am definitely gonna go at a length of a string of 33.912 centimeters. How about the area? What does happen to the two? What happens to the two? Where does the two go? Well, it goes all the way here, right here. That's why it's been always easy for me to remember the equation. I remember one, and then I remember to push the two all the way here for the power, for the exponent. So it's 3.14 times what? Times 5.4, but to a power of what? To a power of 2. All right. So that's equal to 3.14 times. I don't know what 4.4 is. I just know it's like 19 point something. No, I'm mistaken. 29 point something or 30. No, I think it's 29. 5.4 squared. Yep, 2916. And now what do? I multiply. Oh, does that make sense? Yeah, 30 times 3 is 9-ish. Yeah, that does make sense. 915624. 915624. Can someone tell me what's the unit here for the area inside space? Centimeters with a power of 2, as Ty said, centimeters squared. Done. Okay. Are those two smaller ones easier or harder than the first two? Can someone tell me how different is their shape compared to the? They're easier, which so Ty's answer makes sense. What are you shown already on each of them or in each of them? You already shown the radius, which means do I need to do any division by 2 or just do I go straight to the formula? Straight to the equation because everything is ready for me. This is radius. They even tell you, look, you don't have to guess. R equals 2.5, not D. D is diameter, R is radius. They're already telling you just proceed. So here it is. Yes, exactly. So this is 2.5. So it's 2 times 3.14 times 2.5. I can do this in my head. This is, because 2 times 2.5 is 5. Yes. So 15.7. What unit did they take things in? Millimeters. Okay, something different than centimeters. All right. Last one. Sorry, I mean, next thing is the area, which is 3.14 times 2.5, but squared, or times itself. When you, everyone, remember, squaring, everyone, just so you know, again, I'm pretty sure I repeated this before. Squaring is not the same as doubling. Doubling, you multiply by 2. Squaring, you multiply by the thing itself, like you multiply the number by itself again. So if I ask you, double, what's the double of 7? You're like, oh, it's like 7 plus 7, or 7 times 2, which is 14. But then I ask you, what's the square of 7? You're like, whoa, that's not 7 times 2, that's 7 times 7 itself, which happens to be 49. By the way, whenever you square, you get more than you double. Whenever you square, I think so. But always remember, when you square, your answer is always more than you double. Excuse me. 19625. Thank you. 19625, which is in millimeters squared. Done. Okay. Obviously, yes. Obviously, the next one is the exact. It's not the exact same idea because you have a radius. So I don't think it's really. Yes, there's no need to go through it as long as you do the exact same amount of work. Okay, let's look at trapezoids. So go ahead, flip the page now. Please. Yes, absolutely. So yes, trapezoids are tricky, not because of their geometry, because of the way they could line them up. Sorry, not line. I mean spin them, and then you're like, which one is height, which one is base. So let's go to the third page. There we go. Select all, and then zoom out. Or I mean zoom in. Copy. All right. So I'll keep this up here. New, don't save, paste. Okay. So first of all, sorry, let's look at the first trapezoid. Everyone, pencils down. I just want to discuss the shape of the trapezoid with you. Okay. Um, which two sides here? Everyone, listen up. Come on, pencils down. Don't copy. The way you understand it will tell you where the numbers go. Which two sides here are parallel? Which two sides here are parallel? Are basically going exactly like this, or like which ones? So what are the numbers associated with them? But trust me, I want you to think that way whenever you see a shape like this. What are they? So everyone, look, 9.1, and those are your A and B. Go ahead, right there. By the way, doesn't matter which one becomes A and which one becomes B. No, some people like to put the A as a short one. Some people like to put the B as a short one. Doesn't matter. So randomly, everyone, I'm gonna choose. In red, I'm gonna put this to be A. Oh, but you're right. I cannot do it without putting proper brackets. All right, this is my A and B. So can you tell me then, what's the one that goes from A to B always? That would be the what of the trapezoid? Starts with H? The height of the trapezoid. Great, thank you. Go ahead and put H near the 18.5. Done. Now we have all the numbers that we need. But for perimeter, what four sides do we have? Ty, what are the four sides of the outside of the shape? 19.5. Great. What do you do with all of these four sides for perimeter? What do you do for any perimeter? Except for a circle, because it has only one side, one curved side, you add them up. So everyone, let's do this. Now we copy. Go ahead. So I'm going to start with 19. I'm going to go to 6.8. Come on, copy with me. Then I'm going to go to, I believe it's 19 point something. Yes, 19.5. and then I'm going to go to 9.1. How big is that? Well, let me do it in my head. I like to do the ones without decimal first. So 19 plus 6, that's 25. So the height, you mean? The height. Yeah, because it's inside. Remember, inside does not factor in perimeter. If I ask you right now, question for you. If I put you right now on a big like Bristol board and I wanna trace you, am I gonna trace the inside of you or the outside? Ex- that's the point. But look, Jelly. What's inside from your top of your hair all the way to your feet? That's your height. You see what I mean? When you do perimeter, you never care about the height. You care about only about the outside. All right. What is that in mentally? 19.6 is 25. Come on, I want to train this muscle. 25. 25 plus 19, 44. 44 plus 9, 53. All right. But that's only the non-decimal. So 53 up to no decimals. Decimals would be 8 plus 5, which 0.8 plus 0.5, 1.4. So did you get 54.4? Told you. In what unit? Trust me. The more I let, the more I know. By the way, even at my age, with 25 years behind me, helping and doing math, I find myself sometimes if I don't do something for like a couple of months, for example, or a term, like if I don't teach a course and they give it to me again, I'm like, what was the equation again? And I've been doing this for 25 years. So imagine you almost never doing it before. Okay, now we get to the harder part. What is the area of a trapezoid? You see, that's why I teach you how to. No, and that's why I taught you how to label it first, and just wait until you get to use it. What's the equation? Okay, everyone, look. Here's the equation for the what? For the trapezoid. Look, P. Sorry, P. Yes, it is. P. Not P. A. A. Everyone, just pencils down. Don't copy this. You don't need to copy it because it should be right here. Area of a trapezoid is equal to what? It's a fraction. Okay. What's inside the bracket? The A plus B. What's timing it? Times H. Did we already label A, B, and H? No, right here. Those ones. A, B, and A. Go ahead, label them. I always want you to label diagrams. Trust me, it is good for you. You know why? Because if you labeled right, look everyone, if you labeled right, then usually you should get the equation done right. But what if you still mess up on the equation? Do you still get part marks if you labeled right? What do you think? Yes, because you told me I know how to start things. I know where they should go. I just messed up when I plugged in. I'm like, no problem. You at least started right and you get some marks. So it's what? It's A plus B times H over 2. All right. Can someone tell me what's A from the labeling? Come on. What is A from the labeling? Come on, just say. No, no, no. Small a, the small a. Like I'm talking about this one. Jake, look. I'm talking about this small a. Because we already labeled it. Yes, I labeled A to be this side and B to be this side. So 9.1, go ahead. 9.1 plus, what's B? 6.8 times the height, which is the new one now, which is 18.5. Oops. All divided by what? 2. Always 2. Always 2. Never another thing to divide by. No 3, no 4, just 2. Okay. Can someone tell me how to do this? Come on, focus with me. I always use what when I plug in things like this? What's the rule you learned in grade 8 and 7? And so what's the rule? So what's the name of the rule? Bed mass. Bed mass starts with what? With B. And B means bracket. Guess what? I'm forced to do the brackets first. Not a problem. It's easy. So what's 9.1 plus 6.8? That is 15.9. I know that. Everyone, 15.9 times 18.5. All divided by what still? Yeah, I haven't touched the 2 yet. Come on, everyone. Copy. All right. I'm just going to jump to the final answer, okay? I don't want to write. I don't have enough space, and I don't think you do. I'm not going to write something divided by 2 and then the final answer. I'm going to do the whole thing on the calculator right now and then divide by 2. 15.9 times 18.5 divided by 2. Right there. Boom. That's the area. Can someone tell me in what units? In what units is the... Yeah. Remember, everyone. Yes. If you do area in yards squared, for example, sorry, if you do areas in yard, or if you do length in yard squared, I have to take half a mark off. Your unit has to make sense. So 147. Here you go. Yep. 0.75 in yards squared. Okay, let's do another trapezoid. I mean, we still have time, so let's look at which one should we do. We could, by the way, does this look easy enough? Yeah, because it's a trapezoid that's just been what? Turned 90 degrees. So, you know what? Everyone, I'll help you out. I want you to label, and then you can go home. And any ones you didn't finish because you didn't know which A, which B, which one's A, which one's B, which one's C, you know. So here, or top and bottom. See, that's the thing. Yes, but it has to be the parallel side. So everyone, I want you to label this. Go ahead. For this one, go ahead. Where's A? It's right here. Where is B? It's right here. And where is H? There you go. Yes, H is the inside. That's the whole idea. A and B are the outs, or are a couple of the outside. Okay. How about this one? Hmm. I know. I know. No. She's on to something. If she not misread, if she misperceived this, she's right. They tricked you into thinking that, oh my God, those two are parallel, and also those two are parallel. But it's not. Let me teach you. Let me teach you something here. Question for you. What's this one? What's this one? They're connected. Interesting. Which ones are connected here? The top and exactly. The two that are connected with the height are your A and B. The two that are connected with height are your A and B. If you follow that, you will never mislabel. So this is A, and this is B. So where's H? In the inside, which is this guy. Okay. So everyone, go ahead. A is that. Yeah, go ahead. Yeah, what's up? Yeah. Can someone tell me now where's A and B? Why? Because those two are connected with what? With the height. You see, whatever gets connected are your A and B. Done. So go ahead. This is A, and this is B. What's up? What? Well, Miss Sandra is outside, so maybe she heard it and she came to investigate. I didn't.
I heard one like 10 minutes. But I
No,
didn't hear what you.
boy, I have I have good hearing, but even that I didn't hear. All right. Okay. How about this one? So because which ones are connected? Are those two connected? No, look everyone. Those two are not connected. There's no line between them. Ah, those two are connected. There's a dashed line between them. So, as Ty said, this is A, this is B, and the connector is always H. Nice. Okay, which ones do we still need to label? We label these two. We label these two. Okay, let's label this one. Which ones are connected? Yes, those two are connected. So A, B, H. Nice. So since we labeled all of them, let's just choose one to do for the next 5 minutes, and then we can just call it a day. So which one should we do? Top stack, but it kind of looks like this. Let's look one that looks like a legit trapezoid, if there's such. Do number 5. Yep, it's one of the 3 legit trapezoids we see. Sorry, 2 actually. This one. You're all yeah. So I guess it's the very visible jumping out in your face that they are trapezoids. All right. So obviously the easy one to do first is the perimeter, because I'm just going to add this guy to this guy to this guy because I'm walking on the outside, not even setting foot in. So go ahead, 7.3 plus 30.6 plus 24.3 plus 28.8. Now I can do this in my head, but I do agree with Sarah that sometimes I should be more efficient and use. But you're right. Well, hold on. I am actually no. I'm praising you that you're right. Sometimes we can waste time. Sometimes we should just get on with it.
That was me yesterday. Like, yeah. Go on.
Is that yesterday? No, the day before.
Yeah, no, that was yesterday. That was yesterday.
No, it was. I know the
No,
day before.
because
Because
we did
yesterday,
this.
yes.
Right?
90. Wow, perfect. All right, 91. 91 what? 91. Yes, just centimeter. Because you're dragging a string, just a string, and you're going just around. Now the area is where you use your labeling. You never need to label for the perimeter. You just add things up. The area is the one that you need to label. Okay. Bracket, bracket, times. Okay. Can someone tell me what's my A? Like what goes in here? Plus something here times something here. All right. What's my A? How much? Yep. 7.3. 7.3. Don't forget the bracket. There's a bracket here. Don't put the boxes. I'm just putting the boxes to show you that. 24.3 here. And then times, what's my height? Connecting. What's the connecting height? 27, solid, no decimals, great. All right, let's do the bracket first, because that's what BEDMAS tells you. Equals. Yes, we're doing the number 5. So 7.3 plus 24.3, 31.6. Okay, 31.6 times 27. All dividing by 2. So how much is that? Let's see. 31.6 and 27 divided by 2. 420. Yes. 426.6 in what unit? See, centimeters, but with a square.
I said it really fast. DM squared.
By the way, I
Centimeters.
sometimes I exaggerate in the size of the square. I mean, I'm not gonna take marks off if the 2 is as big as the numbers, as long as it's placed right here. But some teachers always want it to be like legit a smaller handwriting or smaller font, because that's the way. Look, I mean, look, that's the way it appears. Just give me 1 second. Look, everyone, that's the way it appears. Oh, not here. Sorry. Yeah, see, like that. But obviously, you know what you're doing, so I'm not gonna take it against you if you don't write as legibly as you're expected to. That's fine. Okay, so that's how you do trapezoids. So today we learned a rule that, or a trick in trapezoids that we didn't discuss when we did this. And the trick was, how do you decide which one is A and which one is B? By seeing which ones are connected with the height. The two that are connected, look everyone, the two that are connected are the A and B. The two that are connected are the A and B. The two that are not connected are just the two extra sides on the side. And that's it.